Welcome everyone to today's webinar. I am Brian Zimmerman with Becker's Hospital Review. We will begin today's webinar with a presentation and we'll have time at the end of the hour for a question and answer session. You can submit any questions you have throughout the webinar by typing them into your control panel in the space labeled Enter a Question for Staff and clicking Send. We are looking forward to hearing your questions. Additionally, in about a week following the webinar, we will be sending you a copy of the presentation to the email you used to register. At this time, it is now my pleasure to start today's webinar by introducing our presenter. Stefan M. Kovac is the Director of Education at Healthmark Industries located in Fraser, Michigan. He has been in the hospital field for over 37 years. He started his career as a sterilization orderly in 1975. Stefan has a BS from Central Michigan University with a major in biology and history. Stefan is active both on the state and national levels of various organizations, having held many positions. Stefan was the educational chair for AORN Specialty Assembly for SP/MM 2006 to 2010. This was a volunteer position. Stefan has received the IAHCSMM Award for Honor for his dedication to improving the role central service plays in the hospital. Stefan has also been named by HPN as one of the most influential people within his profession. Stefan, I'll now turn the floor over to you.
Thank you very much. And again, welcome everybody, and thank you for taking some time out of your busy schedule. Fun with sonics. We're going to talk about the variables of sonic cleaning, the different types of equipment, and that you work in a dynamic environment, and that environment is something that affects every patient in the hospital. It's just a little picture of me there of who I am in case you've never met me before. I have a quick company mission of what we try to do here at Healthmark, and the next one is our policy. And this is part of it, this webinar, and our commitment to education. During this program, we're going to quiz or poll you at different times, and we're going to start out with a couple poll questions right now. I'm going to hand it over to Becky. Becky?
Wonderful. Thank you so much. Okay, I just launched our first poll that you'll see on your screen now. And this question is asking, what department do you primarily work in at your facility? So if you could please select one of the options below. I'll give you guys just a few moments here. We have sterile processing, operating room, infection control, dental office, or other. And I'll give you guys just a moment to vote. All right, and it looks like 54% are from sterile processing. We have 8% from operating room, 26% infection control. We don't have any from dental office, and then 13% are from another part of the department. Awesome. And I'm just going to go ahead and launch our second poll quickly as well, which is just asking where you are attending from today. So it should be a simple answer. We have either the US, Canada, or if you're from another country, we'd love to know as well. So if you could answer those quickly for us. Awesome. And looks like we had 93% from the US, 5% from Canada, and 2% attending from another country. Awesome. And Stefan, I'll hand it back over to you to continue the presentation.
All right, thank you very much, Becky. Well, got a lot of people from all over the world, and thank you again for attending. As with any presentation, we have objectives that we want to try to meet and make sure that we get through the program. So I want to increase your knowledge when it comes to sonic cleaning. I want to talk to you about the 10 factors that impact how a medical sonic cleaner performs. They're very important from what you do every day. Review the appropriate standards and guidelines that pertain to medical automated washers and, in this case, sonics, and share a simple quality improvement process to help ensure your medical sonic cleaner is performing correctly. So let's start out with the definition to make sure that we're all on the same page. A sonic cleaner is a Class 1 device. Class 1 device is also a bedpan. Might be strange, but a sonic cleaner doesn't have to put a lot of information out there on what it can do and how it can perform because it is a Class 1 medical device. They're designed for fine cleaning of medical devices, not for disinfection or sterilization. They're used to remove soil from joints, crevices, lumens, other areas that are difficult to clean, where you might not be able to get it by regular brushing and flushing and so on. It's there to really do some of that fine, deep cleaning you need. An ultrasonic cleaner is considered a piece of medical equipment within your facility. Your biomed department is tracking it. It has a tag, and that's very important when we start to connect the dots, how you use it in your department and how you should track it. The Joint Commission, and this is very important because many people do get surveyed by Joint Commission, or it could be AAA or whatever you use, but that's very important because you want to get your CMS certificate. Joint Commission requires accredited hospitals to maintain medical equipment inventory. As we said, a sonic is a piece of medical equipment. It also talks about the hospitals or medical facilities need to identify activities in writing for maintaining, inspecting, and testing for all medical equipment on that inventory list. So for those of you who might or might not be testing or might not do it as frequently as you should, by these standards, that is something you should be doing. And we're going to address that with the standards and guidelines and talk about it. So again, mechanical cleaning equipment and sterilizers do fall under this category. As you'll notice on many of my slides, I will put the references on where I get the information from. So one of the references that I'm using today is Amy. And the main reference is ST79. And this slide may seem a little busy, but you'll get a copy of it. This is showing why you use a sonic, why you should be testing it, and how frequently you should be testing it. You have it within the standard of 7533. You also have an annex, Annex D, which supports the work on what you're doing and that you verify the process. And also in 7533 section, they talk about mechanical cleaning equipment and that you should be testing it at least weekly, preferably daily. And if you have major changes to it and upon installation. So again, these are some places you can go back and highlight within your standard to make sure that you are meeting that guideline and that standard when it comes to your sonic cleaner. So who's telling the sterile processing area, or the spa as I call it at times, to use a sonic cleaner and why? I've only taken 2 examples out of the many, many instrument manuals. And in those instrument manuals, in the IFU or in the part of the catalog or manual, it says the best method for thoroughly cleaning delicate micro instruments is to use an ultrasonic cleaner. Most instrument manufacturers recommend ultrasonic cleaning as the most effective way to clean surgical instruments, particularly those with hinges, box locks, and other moving parts. So if you're buying surgical instruments and you read the IFU or you open up the catalog or the manual, they're probably going to be talking about using a sonic cleaner in some part of that cleaning process to get that medical device clean and functional. This here is an actual taken from an IFU, and you see the source there. It's one of many companies. And I'm used this as an example as part of their cleaning process. If you add all the time up, you got 15, 16, 17, 18, 20 some plus minutes, part of the cleaning process. But if you look at what's highlighted, this IFU states you should have a minimum of 15 minutes to clean those items at a temperature around 40 C and prepare newly made detergent solution using an enzymatic cleaner or an appropriate detergent. So this IFU states this is how you need to clean the implants, instruments, and the cases. So if you were ever surveyed and a surveyor asked you, why are you set at a certain time? You can say for these sets of instruments, it's 15 minutes. How? You refer back to the IFU. So we will touch on this later. There is no one standard time right now. It is based upon the instruments in the IFU. And this one is 15 minutes, not 5, not 10, but 15. And these are some very common instruments that are used in departments that have orthopedics. That's why I sort of picked this one out. So we're going to do some basic sonic facts. We're going to review how it works. Why is degassing important? Some basic principles. Tie it up with a slide on the 10 factors of cleaning, and then look at the verification process and go from there. So how does a sonic cleaner work? A sonic cleaner works. It is energy in the form of wave motion, which is above our audible level. High frequency sound, it's above 20 kilohertz to produce an effect called cavitation. It implodes inwardly. The high frequency sound is created by the transducers, and then it goes through the bath. And this here's one of the few diagrams. You plug it in, have a generator, takes that, puts it into the transducer, and goes through there. So step one, I'm going to break it down into 3 easy steps. You're into the science of it. I can gladly send you many technical articles that'll break the steps down more. But first, the sound waves from the transducers radiate through the solution in the bath tank. They begin to cause alternating high and low pressure in the solution. Then during the low pressure stage, microscopic bubbles are made. This is the start of the cavitation process. During this step, step 3, high pressure stage, the bubbles begin to collapse inside and implode and go, boom, not explode, but implode. It's this action that gets into the surfaces of the medical devices. It is this cavitation. And these bubbles are created millions and millions of times throughout the solution. And they are imploding and creating like small little vacuums in all the little nooks and crannies that you can't get with your brush or the wipes, the lint-free wipes you're using. And it is pulling this bioburden, this debris that you have into the solution. And it's that implosion or that cavitation. So the basics, again, is a process of additional deep cleaning action. So you've usually done some pre-cleaning. The medical devices have specific exposure times to be cleaned properly. So you need to follow the device manufacturer's IFU for the correct exposure time. Following the cleaning, instruments must be thoroughly rinsed. Think of your dishes. When you pull them out of a sink, they have that suspended soil and grease or food on it, and you rinse it off. It is the same thing with the sonic. When you pull it out, if your sonic doesn't have an automatic rinse, you still have to rinse it out before it goes to its next stage. And when you read the IFU, it will say rinse thoroughly. If a medical sonic cleaner is being used on eye instruments, follow the recommendations from that manufacturer, but ST79 has a specific annex that deals with eye instruments. And again, briefly on eye instruments, some you cannot use detergent or enzymatic, and some you just have to use regular distilled or deionized water. And that'll be very specific on how to use it. So again, with eye instruments, you follow the IFU from the manufacturer of those eye instruments, those surgical instruments. Now back again, you want to use detergent formulated specific for medical ultrasonic cleaners. That is very, very important. You don't want to go and pull something that isn't made, because the detergent itself increases the surface tension within the solution, and then that helps the cavitation process. So you want to make sure you're using detergent that is specifically designed for sonic cleaners. The cleaning solution in the ultrasonic should be changed whenever detergent is visibly soiled, at least once or twice a shift. It's very subjective. Follow the IFU for your detergent and the sonic. And this is very important. As many people as we have right here today on this webinar, subjectively, we could all say that that bath looks dirty or it doesn't. The more soil or bioburden you have in that bath, that begins to impede the cavitation and the cleaning power. And many of the new models, they are changing after every use. And I hear this question, well, Steve, my sonic cycle is longer. Well, the total could be longer in the sense of you're starting with a new bath, it's degassing, it's draining, and so on, where you're just used to putting it in, running it for the 15, 10, 20 minutes or whatever it is. So that total cycle time, because it's from when you put it into the very end, might be longer, but again, it's giving you a fresh bath. And you need to understand that when you're buying a new sonic cleaner. So again, newer models are changing it every time. Medical ultrasonic cleaners, again, clean by a process called cavitation, imploding, not boom, exploding. So the use of the correct type of tray is very, very important. Plastic will tend to absorb the energy. So you don't want to use plastic trays because it will decrease the cavitation and it reaching the instruments. Load your instruments properly, open the box locks, take aparts, lumens. I'm actually going to show you some very good pictures on how you should load your sonic cleaner and ways to enhance that sonic activity, that if you don't open it, it will not clean as well as it should be. You must sort and segregate different types of metals, and many people can put plated metals or probes and that in there, and the mechanical vibrations or the cavitations can cause flaking. So again, as with anything, you don't mix metals, know the type of metal, the instrument that you have, and many times in the IFU it will say, do not put in a sonic cleaner. So again, sort and segregate, know what's going on. Where do you get that information? I might sound like a broken record, but it's back to the instructions for the use. That manufacturer who designed that instrument knows what's best and the best way to clean it. They have done the validation, and that's what's very important. So the ultrasonic equipment should always have a cover or lid to prevent aerosolization, whether it's a tabletop or a big unit, you put that back on there to prevent the aerosolization. To ensure proper medical sonic cleaner is working properly, what do I say? Follow the original manufacturer's IFU, but also follow the PMA. And I have found this, and it is a shame that sonic cleaners seem to be like the stepchild in sterile processing. We don't tend to follow the preventive maintenance in the pictures of the neglect I see. It's there, oh, it's on an ad-need basis when it breaks down. Well, many people think as long as it's humming and working, it's working, and I'm going to show you different. You must verify your process. You must trust, but verify. You must document your resorts, document your reports and your results, and you have something to go back on. Again, if you're asked to show them, that's very, very important. But again, that preventive maintenance contract and by qualified people. Make sure whoever you're using has been trained to repair that. And just because they might have know how to use one unit, they should be trained on your unit as well. Degassing. Degassing is a key. And as I said, many of the new models, they already have that built in, fills the tank, degasses, even though you put the instruments in there, they degas, then they run the cycle. They've gone through a validation process of that. And degassing is something that there is trapped air in solution. And this we have to accept. There are physicists and chemists that if you read, when you have a new tank or you put water in, there is trapped air. The degassing is releasing that air because air impedes cavitation. If there is trapped air, just like a sterilizer, if there's trapped air in your sterilizer, I try to use that analogy, that sterilization process won't work. So you are degassing it and freeing up that air. And so you can get maximum efficiency in the time that you are going to use it. Degassing of the cleaning solution is important. It's helping you achieve satisfactory cleaning results. And if you're using no cleaning solution, such as with your eye instruments, you still have to do it. The time required for degassing varies considerably based on the tank's capacity and size and the solution temperature. And where do you get that information from? The manufacturer, the Sonic, will say that before you begin, you degas X amount of minutes or whatever. Again, air impedes or reduces sonic activity. Excuse me, the next slide. I need a little glass of water there. So when we think of sonic cleaning, I've given you a few things that can reduce or impede how well your sonic will work or clean those instruments. One is air, foam and bubbles. And I'm going to show you some pictures. Foam, which is air, if that is too much detergent, you have too much foam, that will impede and can impede the sonic activity. Too high, too low of a temperature, think of molecules moving. And the temperature is important for your cleaning solution. That works at an optimum range. If that's too high or too low, that cleaning solution won't work as well. Poor loading technique. That sonic could be working properly, but if you just throw the instruments in there and don't spread them out, distribute the weight appropriately, and open it up, you will not get effective cleaning by the sonic cleaner. And some other methods, again, draining of the tank, the soil that is left in the tank. If you're only doing it once a shift and you're running a lot of instruments through there, that soil stays in that tank, and that will impede the cavitation and impede the ability for your sonic to clean. I have something called the 10 critical factors of cleaning, and I want to talk about how they pertain to a sonic. So if you have instruments and you're going to want to use a sonic cleaner, or you have instruments that come out of the sonic cleaner that are not clean, I think if you can understand these basic concepts and principles, you will do well. First, the instructions for use. This is what you need to know about the device. So you have the device, it's a suction or it's a simple Kelly forceps. That instructions for use is going to lead you down a path on how you clean it manually, and if you can or cannot put it in a sonic cleaner, and how you would put it in, and the time for exposure. So the instrument design is next, simple or complex. Is it lumen? Is it hinged? How do I clean it? How do I put it in there? If it's a lumen, if you leave air in that lumen, there is nothing that's going to happen when it comes to be clean. If it's a complex device, how do you take it apart? Spread out the instruments in your surgical tray or in the tray you're going to clean it in. The type of soil is very important. These next 3, 4, 5, 6 sort of go together. No specific order, but they tie into each other. How was it used in the body? Was it exposed to a lot of blood? Was it a knee surgery? Knee surgery is synovial fluid. That's a fat. How are you going to, excuse me, my throat went dry for a second. How are you going to match that up for your cleaning solution? The water hardness. If the water is too hard, you will use more detergent. What is the pH level? It is, if it's stable, good water quality coming in. The temperature. What is the temperature that you are going to be using? Is it at the right temperature, both for your cleaning solution? A cleaning solution, if you're using a protease detergent and you're putting orthopedic instruments in there that have synovial fluid, they themselves will not get it as clean as it's supposed to. So that is all very important. And then on top of it, the right dosage. Too many times I will go in and look underneath and see that it is dry, or there's water in the line, there is air in the feeding line into the sonic. And somebody say, well, it's supposed to be blue, or it's got a little bubbles. So again, that cleaning activity, if you're not getting the right dilution, and how do you check and do that? So the mechanical action, how are you degassing? Do you have the right time and the right amount of time that you're exposing the instruments according to the IFU? This is all very, very important because you don't want to underexpose them. And as you saw on the slide earlier, it says minimum time. So you need to make sure that you meet that minimum requirement. The human factor, that's me. Do you have a Steve working in your department who doesn't load it properly? You can prove that the cavitation's working and it's working fine, but if you don't load it right, spread the instrument or the weight correctly, or load it in the wrong tray, you will not get the cleaning action you're supposed to. You have to do it right each and every time. Did they hook up lumen devices? Did they hook up the minimally invasive items? Also, are they competent? Do you have a competency on how to test and how to load? And can they demonstrate it back? Very, very important. The standards and guidelines. Which ones are you following? If you are being Joint Commission certified and you go through the accreditation, I mean certified, if you get accredited through them, they're probably going to look at AAMI. So are you following the AAMI standards? And like I said, 7533 or Annex D, what are they saying that you should be doing with that sonic cleaner? And how are you record keeping and going from there? And do you have a process, a quality process for monitoring? There's a gentleman, he's at one of the AAMI committees. His name is Frank Myers. He's a CIC person, and he loves to use this line. He goes, if you have a process, you should be able to talk to the process. So can your staff talk to your process of what they're doing and it is repeatable? And what do you have to make sure that it is working properly? How are you verifying that your sonic is working properly? And you are meeting the parameters and cavitation and cleaning is taking place. You just don't trust it. You must verify and document it. And verifying it is very important. And again, how well can your staff repeat back your policy or your process? Is this what I do? This is how I test. This is how I open the instruments. That's very, very key. So what monitors and quality process you have? And I'm going to take a quick second here to talk about AAMI's going to be coming out with a new document. It's ST90. And this is very, very important. It's going to be dealing with the quality process and adapting it to a sterile processing department or sterile processing area. Once this comes out, I would recommend that people start looking at this and applying it and dovetailing it into ST79, because now you can start building real quality into your department. So let's talk about some clinically relevant evidence-based products and applying the principles to the products and talking about what's out there to help you understand the sonic cleaning process. So this study, even though somebody would say, Steve, why are you talking about 2001? This was a study that's 16 years ago, but this was done monitoring in Scotland, where they found 96% of the centers using ultrasonic devices failed to check if they were working properly with some type of cleaning efficacy test. Now, I can tell you back in 2001, the standards didn't say here in the US that you should be doing this, but products have been out since 2001, and I have myself and others here at HealthMark have been testing, and I will tell you, more than 50% of the sonics that I test failed our test. And then those sonics had to be repaired or brought up to snuff. Now the standards are there supporting cleaning verification. But that's very interesting. And hopefully everybody is doing some type of cleaning verification. This report by this peer-reviewed literature by Dr. Michelle Alpha, I think is very important because it helps you if you do not have some type of pulse flow or retro flow sonic cleaner to clean lumens. This should be, get a copy of it. This should be part of your criteria, your request for proposal for a sonic. If you are doing any lumens, you need this. I'm going to show you why. Another one, Dr. Alpha wrote about cleaning efficacy of medical devices in washers, talks about sonics also and why you should be testing them. Almost 20 years ago, Martin Pfeiffer put an article out on why blood as a soil on surgical instruments and understanding the cleaning kinetics of it, and why you should be testing your cleaning equipment with a blood-based test. And that is very key because blood is your main component, and you want to make sure that whatever soil or type of test you're using mimics the cleaning kinetics of actual human blood. And that is very important. Some other literature, there was a white paper done that said they're supporting organic contaminants that are representative of the soils likely to be found on devices after clinical use. Protein, hemoglobin, and some carbohydrates are very good markers when it comes to making sure that something is being cleaned. Also, I was part of a friend of mine, Miss Denise Coltsworth, and I wrote an article on tray selection, and we started to show that different trays impede the sonic activity, and you should be very careful in the type of tray you pick, because certain trays will reduce the cavitation and the ability of those sound waves to go through, such as plastic or some tightly weaved trays. Another one, if you look, that was in 2010, I talked about the 9 factors of cleaning. Well, we work in a dynamic environment, and I've now added 10. So as we learn, now I believe there are 10 factors that are important when it comes to cleaning. Also, STERIS has a great study guide number 24. It's very comprehensive, and it also comes with CEUs. I would recommend going to their page and downloading that and reading and taking their CEUs. Many of the things I talk about dovetail. This goes into some other detail. But again, all information that would help you understand your sonic cleaning process better. And this is some of the information I use to put this program together. So let's start talking about verification of our process. If you excuse me for 1 second, I'm going to take a little sip of water and give you a break for a second. Thank you very much. So verification of the process. I'm going to tell you, you're going to see this slide more than once because it's very important. Verification takes place all the time. As a sterile processing professional, there's 2 things we must always do. We must make sure a medical device is clean and functional, And the verification process is we are always visually checking, whether it's with our unaided eye, with our glasses or natural eye, or with magnification. Every time we touch something, we are making sure it's visually clean and functional. Sonic cleaning has many processes that need verification, and it depends on your model and type. They definitely have to have their cavitation checked separately, because cavitation and cleaning, while it's happening there, not always take place. You want to make sure cavitation is taking place, and you want to make sure that you're checking the cleaning function. And I've taken this quote from the STERIS study guide on page 6. It says, test soil should mimic the type of soil that may be found on reusable medical devices and instruments. So when you're looking for a cleaning indicator to see if you're removing your soil from the device, or what you're using to test to make sure that surrogate device, hopefully the device you're using is going to mimic the soil you're trying to get off. In most of the cases, the majority of the cases, it is blood. And also, if you have a pulse flow lumen, and we're going to talk about that those pumps are actually working. And I'm going to show you examples of where pumps have not been working and talk about it. Other factors, you should look at the frequency of water quality, your temperature. Are you getting the right dilution? That is very important. If not, and you're expecting to have 1 ounce per gallon, 1/4 ounce per gallon, or whatever it is, and if you're not getting it, you're not going to have the cleaning you think is going to take place. As always, document, record your results when you do verification, and that preventive maintenance agreement must be followed and documented. Quarterly, weekly, monthly, whatever it is, if you don't keep that sonic in good working condition, it's not going to produce the results you want. So, I'm just checking my time here. Verification, like any mechanical device, from time to time, transducers will fail, and I'm going to show you that. Man and equipment is a mixture that breeds failure. When you put man and machine together, failure is going to happen. I'm sorry. That is why we have quality processes, monitoring, quality steps along the way to make sure we're doing it. Given the nature of ultrasonic cleaning, observation of failure is not easy. Just hearing it making a sound is not enough, or seeing some ripples in the tank. That is just not enough. Also, in a series of transducers, one may be failing while remaining units are functioning, and if they can cover it, but after a point, if you lose one or more, you will create dead spots within the ultrasonic tank. And if that's taking place and you don't know it and you put those instruments in there, they will not get as clean as you expect them to be. Verification of the process is supported in ST 79 in Joint Commission guidelines. And we all know it depends on your auditor or your surveyor, whether they know that you should be monitoring it. What are you monitoring with? What are you looking for? I still hear it when I ask at meetings, oh, the surveyor didn't ask me, they did this and that. They could ask you, and if they do, you want to make sure, because if you are following 79, you should be checking it minimum weekly, preferably daily, with something that gives you feedback if it fails on how to help solve the issue. And I've shared different articles on the topics. There's enough articles that support verifying your sonic cleaning activity. Monitoring devices for checking cavitation are commercially available, and they have been for quite a long time. So I am going to share some things that have actually happened to me when I've gone in. I've had a sonic with pulse flow not working where nobody knew how long it was working. Staff felt it was not working for months, and they said they weren't even using it because the instruments smelled bloody when they came out anyways. I've been also where sonic has been making noise, but only half of it has been working. Staff stating for months the instrument seemed dirty. Seems like I put it in and only half of it was getting clean. The sonic wasn't working. They thought it was working because it was making a noise, but they didn't have faith it was cleaning it. The staff did not use the sonic because instruments did not look clean after a cycle. It was just making noise. So now I'm going to show you some actual pictures, and this next one we're going to watch 2 videos. So we're going to discuss it here. Now, I am not picking on the equipment, the company, but this right here, a leak. Now we're going to go to the next video. Now, watch this here. Oops. Got to go to the next slide. Didn't want to go. Give me 1 second here. Now watch this one here. Look at right here. Now, unfortunately, with this machine, you shouldn't be able to open the top. Just so you know, the preventive maintenance was horrible. Notice the water coming from the connector here, and nothing's going through. I hooked our device called a Lumen Check. It opened up. It wasn't clean at all. There was nothing going through. And this confirmed to the staff that there was something wrong. And what it was, there was a bad connector. That's why you trust but verify. This next picture, if you can see, unfortunately, it deals with my product. But yellow means you've had cavitation. Green means there has not been sufficient. And our TOSI is in the middle of it. I checked this tank, and we're only getting cavitation in 1/3 of it. Come to find out, underneath, somebody had shut off two of the generators, and that whole 2/3 was not working, but the other side was working. We changed it, put it on, did my sonic checks, boom. At least we know there was cavitation working. They had other issues, as we won't get into, but again, the staff said it wasn't working. What were they testing? Was they got something in? We found out it was. Now they can work on the other issues. Now they had it, all the tank was working right. Somebody shut it off, but they don't know what. Unbelievable. So, no big deal how long this was going on. Staff had complained the sonic was not working. Staff was using all different times. They were changing it. We came in after 5 minutes, no color change. They had no idea. Opened up on the bottom, looked at it. The transducers were all falling apart, falling off. So how do you expect it to work? How do you expect your staff to be working and having equipment to work if you don't trust but verify? And that is very, very important. This here is a picture of another sonic, but it is got the transducers on the bottom. So that is, look how nice and clean. Oh, there's a little dust bunnies over there, but look how nice and clean it is. Now we're going to go back to Becky, and she is going to open up some poll questions. Go ahead, Becky.
All right, awesome. Thank you, Steve. I will go ahead and launch our first poll question that you will see pop up on your screen now. And this is just asking if you have a sonic cleaner in your department. So please select yes or no. And we'll give everyone just a few seconds here to submit their answers. All right. And looks like we have 87%, yes, they do have a sonic cleaner in their department, and 13% do not. And that brings us into our next question that I will go ahead and launch here. So if you responded yes to the previous question, please answer how many sonic cleaners you have in your department. So do you have 1, 2, or more than 3? And we'll just give everyone another moment here to respond. Awesome. And let's see, 52% have just 1, 29% reported 2, and 19% reported more than 3. And then we will go on to our next poll question here. And this question is asking, do you check your sonic cleaner at least weekly for cavitation independently from the cleaning function? So please select yes or no. And we'll give everyone just another moment here. All right, I will go ahead and close that, and let's see our results. 66% said yes, they check it weekly, and 34% reported no. And just one more final question for our audience that I will go ahead and launch now. And this question is asking, do any of your sonic cleaners have the ability to clean lumens? So hook them up to a pulse flow or retro flow system. Please select yes or no. We'll just give everyone one moment here. All right. And the final results for this one are showing that 59% said yes, and then 41% reported no. And I will go ahead and pass it back over to you, Steve, to continue.
Well, thank you, Becky, and thank you all very much for doing the poll questions. And for the 13%, roughly, if I remember correctly, who don't have sonics, you might want to look at it. I know space and footprint of a sonic is something to be considered, but if you are cleaning medical device, I think having a sonic in your department is very, very important. So again, I'm repeating this slide. We're going to now go into a little more verification. The process entails a lot of things, and I hope we've started to show you the importance of it. And you might want to do water, temperature, your cleaning solution dilution, also testing, does it clean and does it have cavitation, but also make sure your preventive maintenance is being followed. Also, again, the standards support this. There's articles support it. Transducers do fail. I've given you some examples. pulse flows fail, not only the pump, but the connectors. And if you don't check it on a regular basis, you are going to have issues. So, so where are ways to do cavitation? And again, there's a difference between cavitation and checking the cleaning. You want to make sure there's cavitation. Traditionally, and I'm going to give my age here, and it's not used much, there's a ceramic disc test, and that's where you would put certain ceramic discs and you would put lead on them and you drop it in and run a certain amount of time and pull it up, and then you'd have a chart to compare it to. It was subjective, but it was also how hard somebody put the lead on it. I'm pretty intense, as some of you might know me. I could have put more on and not enough. So again, that is all subjective, but that is something that's been used. There is a foil test, and that is also subjective. We're going to talk about it. And there is a Sonocheck, which was made specifically for cavitation. Again, we're talking cavitation. We'll talk about cleaning in a second. As you can see to the right there, there's the probe. It's very expensive. Not many people have it. But what also with the probe, you have to take the lid off to check it. So it's not very practical. I do have one when I go in, but you have to find a way in the automated, how do you get the lid up and go from there. Now the foil test is something people use, but you have to understand how to use it. In a small tank, a little piece could be correct, but a big tank, it might not be, because there's different zones. And as I showed you on the other one, some zones could not be working and you could get a false sense of security. So one of the foil test method is where you actually take a full sheet and put it down and do it the whole length. And then you test and go from there, where with something simple as this product, you can put 3 in the zone. Does it turn green? Does it not turn green? Does it turn blue? What is the color change? And go from there. It's a very simple way to check for cavitation. And the foil test is subjective. And you must remember, when you do a foil test, that foil pieces are left behind and you must drain it and make sure they're not there. And you must have a control. And the subjective part of it is, what was it when I first bought it? How does it compare? How many indentations is there? Is that a big enough hole? Is there not enough big enough hole that has been made by the foil? And there are many different ways to do it. In fact, this one from one company says it must be 0.025 thick, and you must put it in it for only 10 seconds. So you can't go to the dollar store and get it. You must get the right thickness. And how do you do it? You have to make a wire frame most probably and put it down. And you must clean the tank and drain it to make sure there's no foil residue. Can it be used? Yes, but it's not just taking a little piece and putting it inside the tank. There's another way to do it, where you make a 3x3 grid and you do 10 millimeters above, and then you put it all the way down into the tank, and you go from there and you do check it, and then you look at it, and then based upon the foil, is it working, is it not? Again, very, very subjective, but it is something that you can use. The Sonocheck has been validated and shows that the results can be used as to a foil test, so that this product does have a validation study. So you do know its results are something that is valid when it fails, to go from there. So how do I verify the sonic cleaning? If you want to do cleaning right now through the literature, when I put this together, there's the Wash Check U and the TOSI. Those are meant for checking the cleaning. Is it cleaning? Not if there's sonication, but for cleaning and reading the IFUs. So you want to make sure, no matter what you use, does the soil represent what you're trying to clean? Are you trying to clean blood off a surgical instrument or something else? The design, is there a challenge to it? Does it represent the most challenging design of, say, your box locks? Is it supported by peer-reviewed and non-peer-reviewed literature? And that's very important in this day of evidence-based. What is there to support that this is actually doing what it's supposed to do? And the soil represent and correlates to the cleaning kinetics of blood. So how do you check one that does lumens? Your pulse flow or retro flow, depending on whose you're using, they use different terms. Do you have a surrogate device that works properly? Does the test soil represent what you're cleaning? Must check to make sure it's working. So I am now going to run a video here that came off of YouTube by a company showing why you want to use some type of pulse flow sonic. And this goes back to Michelle Alpha's article in 204. Watch this. Now, I have taken this off the YouTube. It's out on the web. The company did use our product at that time, but that showed you if you put a lumen device and you did not hook it up to pulse flow, nothing is going to clean that inside of that lumen. That is just a great example, and I pulled that off of YouTube. It's public domain. So you do not put lumens and suctions like this. You hook them up to the special devices in your washer or your sonic to get that pulse flow. That is vital and important, and Michelle Alpha in her article stressed why you must do this. This here again is a sonic. I'm checking with the SonaCheck with also instruments, the TOSI that comes through, checking the pulse flow to make sure you're actually, the pump is working and you're getting what you're supposed to get to clean blood off of stainless steel or whatever you're doing. This is a good way to check a sonic cleaner, all those factors of cleaning. This is one of the many ways. This here is just a couple. I think that one's a BellyMed. This is a new company. All sonics work if they have correct PMA. You teach your staff to use it. These are just different pictures of different companies that are out there, but these have lumens. You should be checking it. So quality improvement, we're coming up to about the 10-minute mark. We got a few more slides and have time for questions. Quality improvement is so important. This is supported by everybody. We must trust but verify. Put in a quality improvement program. That ST90 is going to be coming out. Whether it's Focus, PDCA, Plan, Do, Check, At, Lean, Sigma, this is very important. You check your sonic. You check it for the key parameters, the key indicators. You do it regularly. You make sure the product you're using has the literature to support it. It's doing what you want. Your staff understands why. And if it fails, why does it fail? How do we change it and what do we go? And we're following the preventive maintenance of it. Now this here is according to Steve. Again, I've tried to look at the literature and with different companies. This is a general guideline. So daily, what do we want to do? Clean and functional. Make sure it's visually clean. If it is not visually clean, we send it back to get re-cleaned. Daily cleaning. Your sonic has to be daily clean. I don't have any pictures and I wish I would have had time. I can show you sonic tanks that haven't been cleaned and they got stuff and protein and biofilm on it. Follow the IFU, wipe it down with a disinfectant, make sure it's clean. Use a lint-free cloth. That's very important. Some of them have seals and filters, solution levels. Clean that trap out and do it. Just like your sterilizer, you don't let that get full of stuff. Clean it on a regular basis according to the IFU or each shift or whatever, and the filters that have to be. Weekly cleaning activity confirms that ultrasonic cleaning is capable of removing soil. Again, that's independent from the cavitation. Make sure the cavitation is taking place. Because remember, if there's no cavitation and you would be running a 15-minute tank empty, that's like putting an instrument soaking for 15 minutes in enzymatic solution. So again, you want to make sure there's cleaning activity and cavitation. Some people are even saying you should be testing with protein and swiping the instruments necessarily with protein or something else. Are they getting clean as you pull them out? And so on, a sample of instruments. There's many different products in that out there. Minimum weekly water quality, depending where you're at. Is the water quality coming in good? Is it got too much lead, too much magnesium? Is it too hard? Or you might do it quarterly or monthly. Your bath temperature, is it the right temperature of the bath? If it's too hot, it'll start baking on. Your cleaning solutions won't work as well as they should if they have too much. And if you have lumens, are you checking that pulse flow activity? So I want to talk about a couple pictures here real quick. Look on your left there. Look at how poorly they've just thrown those instruments in. Look at how this department has opened up. They nestled the pickups correctly. They've opened up everything. Which set of instruments are going to come cleaner? The one on the left or the one on the right? The one on the right should become cleaner because of how they've opened it up and followed the IFU. What is wrong with this picture? These IMS instruments, those lumens, there's nothing going through it. No pulse flow activity. They're just sitting there. Nothing's cleaning that inside. Plus they have them all slowed down at the bottom. Look at this. In this one, they've hooked it up properly. They have all the instruments in the rack. The pulse flow's going. Those are going to get as clean as possible. That is so very, very key and important. And look at this, too much detergent, foaming coming out, too much foam in there. Foam is bad, foam is air. What did we say? Air impedes and reduces cavitation. So you got to make sure you have the right amount. So some questions if you're buying, these are very general, but I'm going to go through them very quickly here. Ask, what frequency is it set for? Some devices like DaVinci require a certain frequency or higher. Will this have that frequency? Can you adjust the time or the frequency? Does it have a sweep? Does the temperature, can you adjust the temperature? What is the warranty time frame? What type of cleaning solutions can I put in the Sonic? What is the service contract and preventive maintenance? What is it going to cost me? How frequently? What type of training do you provide for my staff? How to run it and so on? What type of independent studies have you done on cleaning validation, material compatibility, product specific? Can you do lumens? Can you do a robotic arms? Not all Sonics are created equal. So again, some simple questions to ask. Getting back to this, clinically relevant evidence-based products. Apply the principles to the products. Some tests are designed to challenge the operational level of the cleaning equipment, and some are specific for parameters, or some are just to do cleaning efficacy. Excuse me, a little tongue-tied there. But understand those tests. And you must understand what a test tells you both when it passes and when it fails. Why did it pass? Was it simple to pass? When it failed, why did it fail? What is it telling me? Have daily inspection checklists. I believe it should be shift checklists. Think of your sterilizer. You test your sterilizer every day and you have indicators. It should be doing the same thing for your Sonic equipment. Document your results. Just so you know, since 2001, we have been out in the forefront telling people they need to check and verify their Sonic before the standards were even there. We want to make sure you're doing it correctly. So in conclusion, understand your process. Work with your staff. Your staff knows what's best out there and what's going on. Don't cut your staff out of the process. They are your customers also. Work with your vendors. They know how to work their piece of equipment. Make sure you're trained as staff and they're not just pushing buttons. If you don't know network, ask. That is very important. Call up a colleague, or the next time you go to a meeting, talk to somebody next to you, get their name, network. What are you doing? Why do you do this? What is the service level I'm getting at? All very important. Remember, properly utilized sonic energy can contribute significantly to the speed and effectiveness of achieving the desired level of cleanliness needed. Sonic cleaning is not a technology of the future. It is very much a technology of today. So I want to leave you with this little, what does Sonic mean to me? Sonic cleaners are designed for fine cleaning of medical devices. Only use cleaning solutions designed for the Sonic cleaning process. Oh, and not degassing a Sonic cleaner appropriate can cause poor outcomes in the process. I, in-service and training of the staff is key to successful sonic cleaning of medical devices. G, check your sonic activity with evidence-based products like the Sonic Check, the TOSI, and the Lumen Check. So we're now going to open it up to questions, and at the very end, I'll address how you get the CEUs. So Becky, Brian, do we have some questions I can address? We've got about 5 minutes, and maybe we can go a little over.
Yes, thank you, Steve, for that fantastic presentation. We will now begin today's question and answer session. Please submit any questions you have by typing them into your control panel in the space labeled Enter a Question for Staff and clicking Send. We will try to get through as many questions as we have time for. We've got a lot of great questions coming in right now. I think this would be a good one to get us started. So what does PMA stand for?
Preventive Maintenance Agreement. Each piece of medical equipment, the company says you must change the tubing, you must come in and check the filters. It is in the agreement that comes with how you run your equipment. It should go to your biomed department, or when they install it, they should sit down with you. You should have, if you're using a third party to repair your equipment, they should be part of it, review of it. There should be a document. This is done quarterly, monthly, yearly, so you know these things are being checked. So I'm sorry, I will change the slide. Great point. I should say what the acronym means. It means Preventive Maintenance Agreement. Great question.
Thanks for clearing that up for us. And we have another question here coming in. This attendee is wondering, we have a countersonic that has a temp up to 80 degrees and a timer up to 30 minutes. We usually just up the temp and the timer to 30 minutes for degassing. Would that be okay?
Well, the first thing is you need to check with the manufacturer of that specific sonic. In their IFU, it should tell you what time and temperature you should do the degassing at. I don't know your specific one. If offline, I can help you research it if you need it. But for me to tell you what temperature and time, there are too many sonics, but you would refer back to the manufacturer IFU. And if it says 80 and 5 minutes, 80 and 5 minutes or whatever. I'm sorry I couldn't be more specific, but you have to get back to the IFU. But if you give us your name, I can try to help you find it. Great question again, very good question.
Thank you, Steve. And it looks like we have time for just one more question here. Are silicone mats and holders compatible within the ultrasonic machine?
That's a two-part question. The first one is check with the company of the silicone mat if it's supposed to go in the sonic with instruments or by itself, but silicone absorbs sonic activity. So in my opinion, the silicone mat should not go in because it will absorb the cavitation. And you need to check thirdly with the manufacturer of the sonic, and they might tell you no. So you've got to check the maker of the silicone mat, the sonic itself, the manufacturer. My opinion is I would not put it in there. I believe it will absorb, but you could clean it that way without the instruments, but putting it there with the instruments, I would say no. I don't know, we can go over, but before we do, I don't want people to lose anything. I want to do this closing remarks, and we can do a few more questions. This program is going to give you ISHM and CVSPD. Within a day or so, you will get a specific link that will send you to questions about this that must be filled out and sent back to us. And once we get that either by fax or through email, we will then do your certificate. Now, I have been asked this question, Steve, we're in my department, I signed up and I have 7 people here or X amount of people watching this. What you will do is you will take the quiz off for as many people, but with it, you must get your manager or supervisor or lead person to verify everybody's name that they did attend the whole seminar, so that I know that these people were there. This is how it was printed off, because if I am asked if someone attended, I have to have something to go back to that said this department saw it and this manager confirmed, because I wasn't there to visually see you. So I want to thank Becker's and Healthmark for hosting this section, and you will get a link to a quiz and to fill it out. And if Becker's wants to, if we have a couple more questions, we can extend it. If not, it's 2 o'clock. So Becky, you and Brian, I'll let it go up to you if we want to do 1 or 2 more questions.
Absolutely. I think if you have time, we'll just ask a few more, because we did have a lot of great questions. So I am happy to read off a few more for you.
Okay.
All right. Awesome. This question is asking, can Lumen instruments and or DaVinci instruments be placed on Sonic, or in Sonic rather, without connections?
Well, we're going to go back and you're going to look for the company who you bought your Sonic from, and they should give that to you. You also would talk with DaVinci themselves and see what their IFU states and how they have done their validation study for their different robotic arms. They have the XI, the green, the blue, and the gray, and they will tell you and give you directions to do that. As a video I showed you, if you don't hook up to something and push that through appropriately, you probably aren't going to get it as clean as you should. So you'll check first with DaVinci and look at the IFU, and if it isn't clear enough, you would contact them directly, then contact your manufacturer of the Sonic, and they would have information on how to clean it. My opinion is yes, you should. Next
Awesome.
question.
Thank you.
Okay.
Yeah, thank you for clarifying that. Moving on, we have a question from the audience asking, when duckies or other items have been sonicked for an hour and still are getting dark debris, how long before you consider it is broken or in need of repair?
Well, first off, hopefully you're testing your sonic cleaner, and let's just say in this case, if you test it with something that checked for cavitation and you weren't getting cavitation, that sonic isn't working. You might have cavitation and you might not having any cleaning solution put in, so you're not getting the cleaning activity you're supposed to. So if you're letting something run for an hour and it's still not visually clean, I would check with the manufacturer, whoever is doing the repair and maintenance on your Sonic. And if you found out there's been none for a year, you need to get that Sonic checked out. Just like we have an annual checkup, it needs its annual checkup, and to see if everything is there. Because I have another story real quick. I know somebody who bought a new Sonic and the wires weren't connected. They started using it. It didn't pass the cavitation. One thing led to another. They found out when the company came out, they reconnected the wire and boom, it was working. So if you're not doing the checkups, there's something wrong. And if it's still dirty after an hour, you need to get it checked out by someone.
Awesome.
Okay.
Thank you for clarifying that. Would you like to do one more question, or?
One more question. We have over 350 people are staying on, so people want to hear this, and let's ask it. And just so you know, Becker's will send this out. This is being video and tape recorded, so you can play this back if there wasn't staff there. And Becker's and Healthmark, thank you for doing it. Becky, let's do one more question here.
Awesome. All right. This audience member is asking, when is it best to use Sonic? After the automatic washer or before?
Well, you guys are going to think I'm a broken record, but in a general cleaning process, there is pre-cleaning, manual cleaning. Most then do a Sonic, and then it could end there after rinsing, or it could go into an automated washer and go from there. There are some automated washers that we didn't talk about it. They have a Sonic inside of it, so it would be part of that process, and it would be rinsed and come through. The best way you're going to find out where the sonic works on that medical device is pulling up the IFU and seeing how their cleaning instruction states you have point of use cleaning. The people in the OR should be wiping it off, as we know, sending it down wet and moist or spraying it. You rinse it off, do the pre-cleaning, do the manual cleaning, and most have the sonic cleaning in that step. And if you remember back to one of the slides I had there from Synthes, again, it showed where the sonic cleaning process is. So check with the medical device. Becky, I want to say one other thing. I used many different pictures of sonics. I want people to know they are not saying that those are bad sonic cleaners. Those sonic cleaners weren't up to what should be. No matter whose you buy, if you keep them up to the preventive maintenance agreement and contract and test, they will work. So these were just showing some that didn't get the loving care. It's like if you don't change the oil in your car, I'm from Detroit, that motor is going to freeze up. You've got to do that preventive maintenance and do it routinely. Becky, I guess that's about it. I can't thank you, everybody, for staying on, and we're available through email, and I'll be quiet now, Becky, sorry.
Awesome. No, thank you. I was just going to say thanks so much, Steve, for your excellent presentation today, and to our audience for participating with us. Enjoy the rest of your day, and we will look forward to having you on future webinars. Thanks again, Steve.
Thank you, everybody. Take care. Bye-bye.